Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Two-dimensional materials, which consist of just a single layer of atoms, can be packed together more densely than conventional materials, so they could be used to make transistors, solar cells, LEDs, and other devices that run faster and perform better. One issue holding back these next-generation electronics is the heat they generate when in use. Conventional electronics typically reach about 80 degrees Celsius, but the materials in 2D devices are packed so densely in such a small area that the devices can become twice as hot. This temperature increase can damage the device. This problem is compounded by the fact that scientists don't have a good understanding of how 2D materials expand when temperatures rise. Because the materials are so thin and optically transparent, their thermal expansion coefficient, TEC, the tendency for the material to expand when temperatures increase, is nearly impossible to measure using standard approaches. When people measure the thermal expansion coefficient for some bulk material, they use a scientific ruler or a microscope because with a bulk material, you have the sensitivity to measure them. The challenge with a 2D material is that we cannot really see them, so we need to turn to another type of ruler to measure the TEC, says Yang Zhang, a graduate student in mechanical engineering. Taking measurements of one 2D material on 3 different surfaces, or substrates, allows them to accurately extract its thermal expansion coefficient. The new study shows that this method is highly accurate, achieving results that match theoretical calculations. The approach confirms that the TECs of 2D materials fall into a much narrower range than previously thought. This information could help engineers design next-generation electronics. By confirming this narrower physical range, we give engineers a lot of material flexibility for choosing the bottom substrate when they are designing a device. They don't need to devise a new bottom substrate just to mitigate thermal stress. The research is published in Science Advances. Measuring vibrations because 2D materials are so small, perhaps just a few microns in size, standard tools aren't sensitive enough to directly measure their expansion. Plus, the materials are so thin they must be bonded to a substrate such as silicon or copper. If the 2D material and its substrate have different TECs, they will expand differently when temperatures increase, which causes thermal stress. Thanks for watching. Please subscribe my channel for more videos.